Our goal is to make a huge difference in space exploration. Try to make space a lot more like air travel.
They're coming up soon.
Yes.
That'll be exciting.
It's a great partnership that we have here between NASA, the Air Force, the FAA.
That's good to know. Yeah. John, FAA, we're going to have to get them involved.
So the rocket kind of puts that in a parking orbit.
Okay.
Hi, sir. Bill Lee Rosa. Welcome to Cape Canaveral. How are you? I'm well, sir. Very well. Thanks for coming. Appreciate you.
Well, our goal is to make a huge difference in space exploration. Try to make space a lot more like air travel. You know, if you think about it, it's been from 1903 to 1969. From 1903 when the Wright brothers first flew to 1969, for 66 years. The first part flight landing on the moon. It's been.
So what are we doing here?
Well, this is the launch location for our Falcon 9 rocket, our Dragon spacecraft, which you may have seen parked on the launch pad there. We'll do the first launch of this big rocket next
Coming up
month.
soon.
Yes.
That'll be exciting.
It's a great partnership that we have here between NASA, the Air Force, the FAA, and SpaceX. It's really a great commercial government balance here in the state of Florida as well. It's pushed in, so it's really made all of this happen very, very quickly.
Right. The Air Force has been really helpful for us. So I do think on the FAA side, just because there is a revolution taking place and a big change taking place in the NASA plans and commercial spaceflight, that means the business being matched up the FAA on the space side, which it isn't currently. I do think that is a critical thing.
That's good to know.
Yeah.
John, FAA, we're going to have to get them involved.
We're going to pick.
Okay. There you go. Have you met John Holden, my national?
I'm in National Science.
National Science Advisor.
Very nice to meet you.
And I'm assuming you know.
Yes, absolutely. Nice to meet you.
Okay, that's terrific. So was construction actually done here in this factory?
Yes.
Or in this
is where we do the final assembly of the rocket and the spacecraft. So the manufacturing is currently done in California,
Right.
And then we do our testing of the engines in Texas, and then it comes here to the Cape for final assembly.
And this was an old Air Force launch pad, sir, that was accessed over to SpaceX. A great partnership again to be able to provide them with a great capability and share the land here on a long-term lease.
So what's been the biggest challenge in terms of getting the Falconer going?
Well, the whole rocket's been built from the ground up, so that it's difficult to say that any one particular challenge has been greater than the others because we've developed the engines, the structures, the avionics, the launch operations, all from scratch, basically. I do think some of the regulatory stuff has been challenging, and that's where I think the biggest need is to make changes.
All right.
Yes, sir. And our number one concern, of course, is public safety. And we've been doing the best we can, but public safety is non-negotiable.
Absolutely.
In some places.
Well, absolutely.
So,
We don't want a rocket landing on anybody's head.
you got it, sir.
Right, and we absolutely agree with that. I mean, our goal is to make a much more reliable vehicle, first of all, and secondly, to make a big improvement.
Yeah, in terms of use, I think the idea is that this would help to supply the space station.
That's correct. So we've already been selected by NASA to perform the cargo transport function that the space shuttle was performing.
Right.
And that decision was made about a year and a half ago.
Right.
Leslie Woods.
Nice to see you, Mr. Woods.
Nice to meet you.
Nice to meet you.
Brian Mostel.
Good to see you, Brian. How are you?
Chloe.
Let's go take a look at the
Flight and we're complete the testing on the flight location. Independent physical science that stops the rocket flight and actually goes up if it goes forward. And that's something that we expect to finish in about 3 weeks. All goes point in time, we'll launch
I remember.
yeah.
But you,
And then Tesla as well.
Right, you must have like a lot of matchboxes.
So And I think it's fair to say that this is the most advanced rocket in the world. It's the only rocket that's designed in the 21st century. And the patches you see there are exactly bonded on special thermal protection, because the real big breakthrough that's needed with rocketry is a truly reusable rocket. You know, if we're to make a revolution in space, it's got to be reusable. If you think about any mode of transport, bicycle, plane,
It's just too expensive to, have it disposable.
exactly. And thus far, it's been an elusive dream in space to create a truly reusable rocket. That's what we're going to try to do with that. Kind of heat tiles for when the stage re-enters to survive the heat of re-entry. So on this flight, we're going to try to recover the first stage, and then later we're going to try to recover both stages. Second stage is tougher because it's an orbit that needs a full heat shield, a deorbit engine, control during re-entry. We'll also do practice forward landing, and that'll be kind of the initial phase. And then the later phase will be to have it essentially fly back to the land site, and land on a
Once you achieve, you're outside the Earth atmosphere.
Yep. Basically, with the rocket part, stage rocket, and then a little bit at the top. Yes. So there's a little bit at the top, and then there's basically like a sleeve there, and that section. So the rocket kind of puts that in a parking orbit.
Okay.
And it's about 100 miles below the space station or so.
Okay.
And then that little craft has got its little engines on it, and it maneuvers over to the space station. And
And now at this stage it's unmanned, so you're going to be able to just control that.
Yeah, it's designed to do an automated docking and then return to Earth and just land in the water just off the coast of California. Now, when we go to the manned version, the big change is we need a crew escape system. So sort of an escape rockets in case something goes wrong with the booster. And we're going to do something pretty radical there, which is to build the rockets into the spacecraft itself, so that perfect. This is tough.
Yeah, I'm not an engineer, but I can tell that's complicated. But what's wonderful is to see getting the best possible information. And obviously, we're going to try to see if we can accelerate this kind of collaboration through we put forward. So
It's the right plan.
good. Well, congratulations. This is terrific.
Thank you very much.
How's the car doing?
It's doing great, actually.
Yeah. How do you split your time between car and rocket?
Well, it's usually about 50-50. We should have the sedan on the roads in 2 years. And it'll be the best car on the roads by far. That's our goal.
I'm going to have to test drive it.